Welcome back. In the last episode, we learned about system decomposition. That is how we can break a larger system into smaller, manageable subsystems. So let's continue with our system design journey. In this episode, we will learn and understand how to model a system at a very high level. Before that, let's look into what actually a model is. A model is a representation of a physical object, usually smaller than the real object, that is used to represent that thing. Models can aid in defining, analyzing, and communicating a set of concepts. We create models to understand the various aspects of a system. For example, you can create the model of the Golden Gate Bridge in San Francisco to understand its structure. Or you can create a model of an aeroplane to understand the aerodynamic principles and use it to convey the workings of the airplane. Likewise, we use a variety of models as a part of the system design methodology to convey the function, structure, and internal behavior of a system. We can define a subsystem using a variety of models. This helps to understand the subsystem more easily. Now, software models are ways of expressing software design. Usually some sort of abstract language or pictures are used to express software design. So that brings to our next question. What is UML? For object-oriented software, an object modeling language such as UML is used to develop and express software design. The Unified Modeling Language is a general-purpose developmental modeling language in the field of software engineering that is intended to provide a standard way to visualize the design for a given system. We will use UML as a way to describe various models. There are various types of software models that we can build in order to convey the details of our system. But at the high level, we can classify them into three different types. First, the functional model. Second, the object model. Third, the dynamic model. The functional model describes the functionality of a system from a user's point of view, using use case diagrams. The functional model can be represented via a use case diagram in UML. In this model, we identify the participating actors and all the functions that these actors can perform. Then we draw out the use case diagrams showing those actors and the functions that they can perform. The object model describes the structure of a system. It's all about the objects, its properties, functions, and its associations. Associations here simply means the relationship of an object with the other object. Dynamic model describes the internal behavior of a system. These kind of models describe how objects or group of objects interact with each other. Further, it can help us understand how the state of objects changes due to external responses. We will learn more about each of these types of model using an example system. Let's say we want to build the system design for a concert app, like the website Book My Show. The main purpose of the system is to allow fans to view listing of music events, purchase tickets, and watch live music shows. We will use this same example to create various types of models to represent a system. As I mentioned, a functional model describes the functionality of a system from the user's point of view. The functional model can be represented via the use case diagram using UML. In this model, we identify all the participating users. These are also known as actors, and all the functions that these actors can perform. Then we draw out the use case diagram showing the actors and the functions they can perform using lines. This provides a high-level view of the actors and the functions of the system and who can actually invoke those functions. Let's go through building a use case diagram for our concert app. We start out by laying our actors, which in this case is the fan and the artist. Remember, a functional diagram represents the various functions that an actor can perform. Let's see what are the different operations the fan can perform. The fan can create an account. An account is required before a fan can purchase a ticket for an event. Set a profile. This function allows the fan to set up their public profile and specify the preferences like the location, the music genre they are interested in. This info can be used to show a list of recommended events to the fan. Buy tickets. The fan can purchase tickets for their favorite events using their credit card, debit card once they have created an account. View concept, the fan can attend the event live or in person and be part of the show. Likewise, let's see what are the different operations the artist can perform. An artist can publish the event, provide all the details about the event, its location, its timing, some teaser videos, and even specify a ticket fee. Broadcast the concept. An artist can start broadcasting the live event to their fans so that they can interact and watch the show. Generate reports. Finally, when the concert has ended, the artist can go back and generate reports to view the ticket sales, understand the fan engagement, and collect other stats about the event. So far, we have seen individual functions that the actors can perform, but there can be functions that can be common across actors. For example, in our use case, artists also has to register and set up their account before they can publish any events. They also have to set up their profile like the fans to help their fans learn and connect with them. So both of these functions are common between the fan and the artist. I hope you got a good understanding of what the use case diagram is with this example. We will continue with the journey moving on to next. In the next episode, we will learn about the other kind of software models, namely the object model and the dynamic model. This concludes this video. Please subscribe for updates and provide your comments below so that we can improve this series. Also, the link for the online class has been provided in the description below. Please sign up. Thank you and see you next time.